Well, hello everyone.
I wasn't entirely sure when or when not that intro was going to fade off into our normal, but welcome everybody back to another episode of Sunday Science, or Science Sunday as it's actually spelled out. Glad you could all join us again for another episode. And thanks for sticking with us through my absence the last couple of weeks. It's family, Anywho.
Yep, they were
To
good.
the science.
They were stuck listening to me, Andy. Think about that. They must really like you to hang around. Anyway.
Well, obviously, there's. I'm not going to say obviously people like me, but hey, if you're interested in science and you're looking for a place to sit down and have a fun time learning something that maybe you didn't know, this is always going to be a great place for exactly that.
Indeed. And oh, I'm sorry, I cut you off, Andy. Go right ahead.
No, go for it.
Oh, okay. I was just gonna because last week I brought up to everyone that what you were planning and your upcoming series on environmental sciences, and with Earth Day coming up. Earth Day is Sunday, April 22nd, and you would want to do the series culminating on that date. And,
Indeed.
I figured I would just quickly go over, well, really why I thought that was such a great idea, just from experiences here at the New Jersey Shore, and just very quickly blow through that to kind of wrap up from last week. Here, let me get things started here. All right. Here in New Jersey, at the New Jersey Shore, we have one part of the Gateway National Recreation Area, which is, let me get to pictures so you can see where it is. Okay, you can see right here, I have the arrow. The arrow is Sandy Hook. It's the Sandy Hook unit of the Gateway National Recreation Area. Now, one interesting thing about Sandy Hook is, let's see here.
I was going to say, obviously, I live in the Columbine area in Colorado. You're by the Sandy Hook area when it comes to discussing this. Not everything about a region is tied to a horrific event.
Right. This is not that Sandy Hook. I should have mentioned that. It's not that Sandy Hook.
It's perfectly okay. Like I say, I live in the Columbine area of Littleton, Colorado. It's, unfortunately, things do happen. It's an absolute effing travesty, but
yeah, agreed.
This is a very non-political show, so I just wanted to make sure everyone knew, hey, SciStrike's not talking about Sandy Hook because of a horrific event.
No, and it's a completely different Sandy Hook. And Andy, thanks for bringing that up, because just saying the name Sandy Hook does bring up. I'm sure anyone listening, the first thing they thought when I said Sandy Hook was exactly what you were referring to. Not the intent, obviously, and it's a completely different Sandy Hook.
And then yes. Yeah.
So this one. It's in one of the things there. This is the Sandy Hook Lighthouse. It's in, obviously, Sandy Hook, New Jersey. It's the oldest working lighthouse in the United States, and was built in 1764. It's on the grounds of Fort Hancock, which is one of the areas in Sandy Hook. It has quite a bit of history. Actually, in the I was told by the federal employees there, because they're more than happy to talk about all the history they know, and as long as I kept asking, they kept telling. Apparently, this lighthouse was temporarily in territory controlled by the British, and our folks decided they were going to try to deny them usage of this lighthouse, and figured they would pummel it from the sea with cannon fire, which did impact the lighthouse, and unfortunately had no effect. So there's a little bit of history from that lighthouse. Now, Sandy Hook's it's in Monmouth County, sort of in northern New Jersey, sort of northern central. It's got two sites. This Fort Hancock, that was part of our coastal defense system, uh, starting in like the 1890s, and that continued right up until 1974. It's got over 100 historic buildings and fortifications, which look, oddly enough, like this. And this.
Okay, that prior image that you just showed is
Yes.
Can you give me a little bit more back history? Yes, that one. Can you give me a little back history on that one?
All of these were it's a similar purpose. There's what was a battery of mortars. That's in this area. Little short, fat cannons that just kind of lob. Well, you know what mortars are.
Yeah.
There is. There were a couple of. Well, they had some ordinary cannons. Let's see. I believe this is one here. Here we go. And these were just. This is actually on a side of Sandy Hook where it would not have been. It's actually inside the protected harbor. It's basically just there so you can see what was around at the time. This is near one of the beaches, which is what the heck is it called? Oh, Battery Gunnison. Right. It's got originally it was built with 6-inch pop-up cannons. So-called, for obvious reasons, they would, when not in use, flip up and descend into a large circular area, and only come up when it was time to fire at something. Those were later replaced with permanently fixed 6-inch damn big guns. And those are still.
Yeah, that's a damn big gun.
Yes, that's a damn big gun. Anyway, there's a lot of very historic buildings there. Here are some of the buildings that military personnel inhabited during these years.
They're like perfectly positioned.
Indeed, it was done by the.
It's almost a horror film feeling. It was perfectly positioned.
It was done by the military.
Stepford Wives. Yeah.
It was done by the military. Ooh, you've all heard the voice of our secret guest.
Okay, I was about to say now that our secret guest has gone and announced herself, I will let everyone know that we have been.
The scientist is out of the bag.
Yes, the scientist is out of the bag. So, with this series that we're going to be doing on environmental science, we had no choice but to ask for some other professionals to actually join in and be able to help us with providing the proper content to ensure that everyone is learning correctly what it is that we're talking about when it comes to climate science, because it is it's a kind of a gray area sometimes. I think that a lot of people don't actually consider how much work goes into climate science. So with that being said, I would like to introduce scientist Mel joining the group, and I'm really excited to have you join us. And I think this is going to be a really fun series, Mel. So thank you for joining us.
Thanks for having me. I think it'll be fun too. So
I wish I had some kind of fanfare for that announcement, but I got nothing. But yes, thank you very much for joining us. But
all right,
let me before I eat up your whole show, Andy, I better wrap this up. I do have a.
Oh no, you're fine. You're fine.
All right. Anyway, this is this is where a lot of the military personnel were housed. Here's some more images of that. And what's this one? Not sure what this one is. Okay, this is a view over the salt marshes in that area. This area is also a wildlife preserve. Um, Now, in addition to all of that military stuff of great historical value you've just seen, Sandy Hook has 7 beaches for people to go and recreate. Okay, written down, that would look bad. I mentioned Gunnison Beach. We saw there. It's got a nude beach for the folks who enjoy such things. And let's see what else. There's a holly forest.
Before you
Yes.
get too much further sidetracked, since we
Yes.
are going to be talking about environmental science for a
Yes.
couple of episodes and those sort of impacts that affect our planet and affect our local geology as a whole.
Yeah.
These particular salt flats. Do you by chance know what sort of a time frame we might be looking at to when these might not be shorefront property?
Yeah. See, that's why I thought that's one of the reasons I thought Andy's idea was a great one, because everything that I just showed you and a lot more. There is a lot more there. History. It just part of our nation, part of the United States history is there, and within 50 years, it's all going to be underwater. Now, I find that somewhat disturbing, and this information I actually did not know when I was talking to the federal employees that it's their job to tell us all the history and what's going on and all that sort of thing. Informed me that the plans are laid for the removal of all government assets within the next 40 years or so, because in 50 years it's all going to be underwater. And all of that you just saw is going to be gone. And that which is not gone will be inaccessible. And that's just one of the many reasons that Andy's idea sounded particularly attractive, and I thought it was a really good idea. And that will be the end of my sermon. Last thing I'll do is remind everybody that the other thing that's going to be going on during Andy's series and culminating on ending at the April 22nd show is don't forget there's a prize involved, same as we did last time. It is the Science Denier Kit. That
there are certain things that you just can't say don't happen.
Indeed, and this is it allows you to do a little experiment showing the effects of carbon dioxide and all that sort of thing. So that will be awarded to randomly selected viewer at on Earth Day. So there you go. That's what I got, Andy, and I will stop hogging your show now.
Well, Sai, I gotta say, I think that was an absolutely fantastic intro, and thank you for going out and doing that end of the legwork and getting the photographs, doing the, going out into the field, basically. Congratulations on doing a very good job on that.
Well, thank you, and to make sure I didn't screw it up, although I was actually there at every place that you just saw, accompanying me was a professional photographer who is linked in the description. Her name is Jessica, and you'll find a link to that Facebook page. Anybody in New Jersey? Yeah, there was no fee involved for this, so if anybody wants to use her services, you'll see her in the description. Anyway,
very awesome.
Yeah, she liked your idea too. So, all right,
I think that's
it for me.
I know a lot of times when you bring up what climate science is, it can be very, I guess intimidating would be the right word, because there are so many different facets when it comes to how we've measured climate, how we predict climate models for the future. I mean, even just considering paleoclimatology is such a monumentous task. it's hard to think how people even decided, hey, if I do this, will I be able to figure out this? It's, you know, it's a difficult and tricky subject, but it's also, it's such a widespread part of earth sciences in general that even though it might seem intimidating to breach into and to try and get a good grasp and a good understanding of the sciences behind it, it's something I believe everyone should take the time and learn a little bit about, even if it's just a little bit. Learning how we're actually able to drill into something, take a carbon sample, and look at the past, look at 5 million years ago. That's kind of daunting. It's, you know, it's fun to sit down and watch a Nova special or something of that nature, a Nat Geo, and oh, that's really cool. I'm so glad that people are able to do that. But what are they doing? And it's that what are they doing that I'm hoping to be able to share with everybody is what it is that people are actually doing. Because it's easy to say, oh, we did this, that, and the other thing, and now we have this information. Well, it's not so easy to go, this is what this is, and this is how it works. So I'm hoping to be able to share that with everyone here, and I hope you guys enjoy the series. I know I know personally it's going to be a tremendous amount of fun. And like I say, we have Scientist Mel joining us for this episode or series. And it's just going to be a lot of fun. So for everyone that does not already follow Scientist Mel, I think it's due time that we go ahead and let you introduce yourself and tell us a little bit about some of the work that you do, Mel.
Okay, well, cool. So I'm not necessarily in climate science, but I do understand it. And I have talked at length with other individuals. Oh, I'm all choppy and stuff. It's weird. I'm seeing myself double. I'm not used to the format, but that's okay. So what I thought I would do is show you a little bit of some slides that I did from another talk, which you can actually go and look at on YouTube. I don't get into the particulars of 100% of how they gather the information, but I do have the data there. So if you're kind of behind on climate change science in general, I cover the data, but I don't necessarily get into all of the details as to how they do it. So that's going to make SciStrike in Science Sunday with their series on climate change to be a lot more interesting, is they dive down into the actual science and what it is they do in order to get the data. So that's something I haven't done, but it's a nice little refresher if you're a bit behind and it's the science of climate change. So what I thought I would do is try to show you kind of a few of the slides that I did from that talk about some of the things that we can talk about, that we will be talking about in the series, if that's cool. What do you guys think? Is that okay?
Sounds good to me.
Okay, I'm trying to figure out how I present on this thing.
Oh, you did it before. Just share the window.
That's right. Oh, I'm in charge. I can present my window. Okay.
You can do anything you like. Absolutely.
See, I'm learning new things, and I did it before. So this is what I'm showing you here. This particular, this was from my talk, The Science of Climate Change, which you can go check out on YouTube if you need a refresher course and you're not certain what the data is that they'll be talking about on Sunday Science with their particular series with Andy's show. So what I briefly do is I kind of just go over what climate change is. It's not weather by itself. So it's trends. It's trends in the weather, the consistent changes over time, changes in atmosphere, temperature, sea levels, ecosystems, all of this. And the thing is, it can be measured. So often I get individuals that say, what is this one piece of evidence that is definitive for climate change? I'm like, well, it's not one piece of evidence. If anything was ever just one piece of evidence, then it's not proven, huh? So you have to have lots of evidence from several different sources to come together to explain why a thing is happening. So that evidence comes through the changes in atmosphere, temperature, sea levels, the changes in ecosystems, population numbers, all of these things. Limited resources. As the resources die off, we see changes in population. So all of this is kind of interwoven together. So there is no one substantial piece that climate change is real, because that would not make sense. You have a lot of evidence and you put it together and it explains climate change. So we have the natural greenhouse effect and we have the human enhanced greenhouse effect. So what happens is all of that heat kind of stays a bit closer to our planet. And what a lot of people don't understand is compounds can hold in heat. And so the biggest contributor to global warming right now is CO2. So we have a lot of that particular compound that's in our atmosphere. Well, compounds retain heat just like anything else. And the more we have of that, the more it keeps the heat on the planet. We want some natural greenhouse effect. Otherwise, our planet wouldn't be warm. We wouldn't have seasons. We wouldn't have things like that. But if we increase the amount of those gases that stay in the atmosphere that hold on to the heat, that's the problem. And so carbon dioxide, this is from the EPA. We've got 82% of the greenhouse gas emissions is carbon dioxide. Now, it's not necessarily the compound that could retain the most heat, but it's the one that's causing the problems. And if you want to check it out, this here is the current level of carbon dioxide, 1950. It's pretty close to the same one. We have all of this data from the past. Now, I'm not getting into how we've gotten that data because that's what we're going to do on this show later on in that series. But this is the data that comes to us from NASA. We have ups and downs, and that's true. But the thing is, we haven't had anything go back down since 1950. It's been consistently increasing in the amount, and this is the most we've ever had in, you know, what we can measure from the planet. China is 30% responsible for the CO2 emissions, and we are next in, well, there's other being all of the other countries combined together on the planet. Okay, so those would be like all of the other smaller countries combined together. That's the other 30%. But look at the US, we're 15% in regards to contributing carbon dioxide. So this is something that is a problem for us. And we have to keep in mind, a lot of what we outsource to China is in the form of factories. So you kind of got to put that in perspective.
Yeah, there's a very good chance if we took all manufacturing that the United States outsources, and I'm not saying the United States is the only person that outsources, or not even person, the only country that outsources manufacturing to China, but China has become very profitable on taking in other people's work. And
Right.
if countries worked a little bit more together on, you know, not making it really cheap to screw people over, I'm sure that number would drop significantly.
Exactly. And the thing is China is now, from what I've seen, in regards to reports, is that China is actively trying to work to reduce their footprint. There is legislation in place, but my understanding and I have friends that do live out in China. My understanding is they so rarely enforce those regulations and legislation over there within the country, but it's my understanding they are working towards cleaner energy. So that's a good thing.
Indeed. And I mean, this might be something for future episodes as well. I'm not 100% sure, but most of the industry in China, as with most of the industry in Europe and most of the industry in the United States, is shoreline property industry. So you're not talking on the border with Tibet, there's this factory that's leaching stuff into the Yellow River. Everything is generally coastal based, and a lot of that happens to be the shipping of product from country to country. And
somebody was asking
if
that includes Canada.
So
Right. Somebody asked if Canada was involved with this. If you want to look at the data, I hope it's still there. It's on the EPA.gov. You can look at the Bowden, T.A. Marlin, G, and Andres study. This was from 2017. So if you type in, or if you can't find it, you can go to Google Scholar and type in CO2 emissions and the last names of those authors. They have the raw data there from the individual countries, and you can investigate that yourself if you like.
Well, I'm actually really glad that you just brought that up. I feel like a lot of people don't realize Google Scholar is even a thing, and you know, as many issues as I've had with Google in the past, Google Scholar is such. If you're looking for information, go to Google Scholar first and then search. And no, I'm not being paid by Google. I don't work for Google or anything of the sort, but you're going to get a lot more quality data.
Yes, and the other good thing that you can see with Google Scholar, and this is something that I try to encourage people to take a look at, not all studies are good studies, but the good studies are going to have high citations. And so if you see something that's a fairly new study like 2017, it's not going to have a whole lot of citations just yet. But if it has like more than 6 or 7 or 8 or something like that, that's good. So that's always a good measure. If it's from like 1997 and it's been cited by one person, it's probably outdated or it was crap. So the titles sound really fancy. So don't get too caught up in just finding a title that kind of suits what you're looking for. Check to see where it was published, check to see how many citations it has. And Google Scholar posts that. It lets you know how many times it's been cited, which is really nice. So that kind of helps you weed out potentially, you know, crappy science. Because, you know, crappy science gets published. Somebody said, well, this is a peer-reviewed journal. I'm like, do you realize there's a homeopathy journal?
Yeah,
yeah, realize that.
Just because someone somewhere mentioned it doesn't mean it's actual science. It just means that someone was able to write it down.
Yes.
It's unfortunate we live in that day and age, but I'm pretty sure that day and age has always existed. So
yes. So yes, if you like that data, you can. Sorry.
No, you're fine. You're fine. Yeah.
So if you want to dig into that, just type in Bowden Marlin EPA studies or Bowden Marlin 2017 CO2 emissions, and you can find that paper for that.
Very awesome. These are some absolutely phenomenal slides that you got set up, and I know you're obviously we're moving on to Venus, and just so before you start, I do want to throw it out there so that people, just a little bit of a heads up. Anyone that thinks that Venus is hot because it's close to the sun, that's just simply not the case. Venus is in the habitable zone, and there's a very good possibility that without its atmosphere, it would be a life-bearing planet similar to our own. So I'm sure you have a little bit more to say about that, Mel. I'll go ahead and turn things back over to you.
Yeah, I was just going to mention the Venus is an example of what we call a runaway greenhouse effect. So what happens is if you have an increased amount of greenhouse gases, that is what you end up with a planet. It is so hot there. It is so hot there that anytime we've tried to send tech to check it out, anytime we've tried to send tech there, it's almost obliterated within an hour. And so with this particular atmosphere, if we were to continue on with an increase of CO2 emissions, 96.5% of Venus is carbon dioxide, and that's at 730 Kelvin. Now, if you're not familiar with Kelvin, let me give you Celsius. 457 Celsius. 100 degrees is boiling water in Celsius. So this is 4.5 times boiling water temperature. So, and so the thing is scientists will study tropical ocean areas to predict Earth trends towards this Venus atmosphere. And so CO2 currently, with as hot as our planet gets right now, it's 0.03% of our atmosphere. But you notice, even though it's just 0.03%, this small change in concentration has very large effects on our planet. So if we can, you know, if we steadily have small, even they're like, well, that's parts per billion for our planet is a substantial change. It really is. And so we're going to just continue to see increasing amounts of temperature in that regard. So I'm like giving like a really shorter version of my talk. All right, so this particular one, this is from NASA, and NASA has a whole bunch of stuff where you can go and see information as far as the data they've collected. So this is from 93 to 2017. And what we have is the sea levels have risen 84.8 millimeters as of March 2017. And so we're losing a lot of that polar ice, which means our sea height gets higher and higher and higher and higher. But notice it's at like a pretty steep. We start out with this here, this steady line here. If we drew a line here, that would be a straight line. And then here we've got a super high spike just in 2017. So from here to here. So it's, and that's the thing, this can all be measured. So when we're talking about climate change, we're not talking about just the sea height. Well, that's not substantial. No, by itself, no, it doesn't. But when you couple the increased amount of carbon dioxide in the atmosphere, along with the sea levels rising, this sort of thing.
The decline in ocean salinity and increased acidity. There's a lot of things that start to take place, and a lot of the bacterias that we actually require in our. Okay, I'm getting into what is supposed to be future episodes. I'm going to stop myself.
That's okay. I won't get into a whole lot of it, but I'm just showing a little bit of the data. If you want to sit through the whole talk, I'm just skimming through this because I don't want to eat up all their time. But I do have a video where I talk more about this individually. And so from 1870 to 2000, the amount increased 200 millimeters. So if we're looking at here, it increased 84.8. So we subtract 200 from 84.8. So almost half of the sea level change has happened within the past couple of years. So that 200 millimeters from 1870.
Yes. Sky Strike, I just want to double check and make sure you already have Mel's video for this in the link. Linked in the description, correct?
Not yet. I don't have this this specific video. We will include that when we're done while it's processing. And actually, I'm glad you interjected in this slight break here because Mel, there seems to be a question for you in the public chat.
Okay.
It is as follows. It's from our friend Bo. Global warming versus climate change. What's the easiest way to distinguish between them?
All right.
That's the question.
Okay, global warming, which I will just pop over to this next slide right there. How convenient. It's like they've like, did you guys download my slides off my website? Because you can get them there too.
Well done. Well done, Bo.
All right, global warming. Global warming is the temperature of the planet on any given moment. All right, so global warming, what we see is the entire planet is heating up. All right, now the reasons for climate change essentially is trends in weather and temperature, all of this sort of thing that happens over a period of time. Global warming is an aspect of climate change. It's kind of like saying all enzymes are proteins, but not all proteins are enzymes. Global warming is kind of like it's a, let me see if I can find a word for it. It's an integral part of why we see the trends in weather changing. The trends in weather changing is climate change. And part of that is global warming affecting the way that our weather behaves. Does that make sense? And we can track these weather changes over a period of time and notice that things are not doing what they used to do. And that is climate change. Did I explain that okay?
I personally believe you did, but at the same rate, I come from a family where I was raised by a geologist and a geologist. So
Okay. All right. So what I'll say, let me explain it in another way. All right. So essentially, we have a lot of different things. And the way, if you know anything about biology, you'll understand that there is a lot of reciprocity and a lot of things intermingled and intertangled. One thing affects the other. If you look at wolves and deer in a particular population, if the deer population increases, guess what? The wolf population increases. And then all of a sudden you got the deer population going down and then the wolf population goes down. That's kind of like what goes on with global warming and climate change. The hotter it gets, the stranger the weather is going to be. The colder it gets, the stranger the weather is going to be. So if we have a hotter planet that's increasing in temperature over time, we're losing our polar ice caps. We're seeing a rise in the ocean. And the thing that affects our weather more than anything else is temperature and the ocean. Yeah?
Indeed.
So if we're affecting how hot the planet gets, it causes the ice packs to melt a bit more. We increase the amount of water in the form of ocean levels. Our rain, our hurricanes, all of this stuff, tropical storms, all come from over the ocean.
Indeed.
And so if we have these trends where we have these storms popping up and we have dry spells on the planet, and then we have crazy winters, the change in the planet's temperature is a factor of that, but it is not by itself climate change, but it affects our weather. Is that another way to explain it to where it's better?
No, I think that's actually a very elegant way of explaining it, and this is why this is part of the reason why I think this is going to be a very exciting series to have you involved with. And again, I thank you for joining us.
Well, I was happy to do
this series.
That's what I do.
It's going to be a lot of fun because I know you are a good source of information, and that's always awesome.
Well, I'm so glad to be here. I like science communication, and I like breaking stuff down into easy, accessible parts, and so I'm happy to do it.
Very cool.
Yeah,
very cool.
We have a little interesting, if I can interject for just a second before it scrolls off on my screen and I forget it actually happened, is we have an interesting conversation going on in the public chat. Havoc had asked a while back about cleaner burning fuels and things of that sort, and I just responded with what I'd prefer, which is we don't do any burning at all. Going forward, more solar, more hydroelectric, more wind, and even nuclear. A lot of people don't like to hear that word, but even that.
A lot of people really despise nuclear. But
yeah.
Moving on to that area when it comes to energy production, it's inevitable.
Agreed, and then it was the point was brought up that. He said Havoc once again says he would love to get away from burning too, but production of electricity is expensive via other means, and really that's what we're fighting, is the cheapest way to produce electricity in a lot of areas is unfortunately coal. And I don't want to hear clean coal, because there's no clean coal.
No, there's no way to burn coal in a clean fashion. It doesn't exist.
That's like saying clean poo.
Yeah.
It's just
but I do understand that is the battle. That's what we're. And I'm not going to say, well, we need to just make sacrifices and we all pay $50 a kilowatt hour. No, that's no one.
Yeah, no, I would much rather see thorium come to fruition and actually be used. Indeed. Than someone try and say I can put coal through a filter and make it clean.
Yeah, indeed, but
a lie.
But he does have a good point. He does have a good point that's what we're fighting. And
yeah. See, here's the thing: if you burn anything organic, you're always going to release CO2.
Indeed.
That's always going to happen. Any carbon-based things, I mean, you're always going to release carbon dioxide. That's one of the products of combustion. You can't get around that.
Indeed. It's not going to go away anytime soon. It's one of those aspects of physics.
You could have I've developed clean shirt burning for energy. And it's like, you're still going to release CO2 if it's cotton, particularly. Now, I wouldn't do that with a polymer. That's probably not a good idea. But like, if it's like a cotton t-shirt, I'm going to burn my jeans for energy. You're still releasing carbon dioxide in the atmosphere. But I cleaned them first. It doesn't matter.
Yeah.
It's made of carbon.
I'm
That's
waiting
a
for
very,
someone to. I'm waiting
very
for someone
good
to
way
produce
of
it.
wording it, Mel.
I'm waiting for someone to produce a plant that is just voracious, that just stuffs its little face with CO2, and all the exhaust ports of all of these things we're burning now would be funneled through, and what would come out would be nice, clean oxygen. And yes, I'll wake up from my happy dream right about now. Okay. Please continue.
Okay. All right. So we were talking about global warming's role in record worth. Okay. So if we're looking at this graph, and this, you can go to climatecentral.org, and you can see that there's a heavy spike in upward trend in planetary heat starting about 1937. So right over here where the 1940, we got these little red dots here. We have a huge spike here. So we got to think about industrial revolution when that starts. And then right around this time, you know, you can even, in the historical records, there was huge pollution problems, especially in London, that they had to address. And so once they started putting measures into place, and so in the 30s and 40s, pollution was really, really high. And so they started putting measures in place to try to limit that. Then we took care of it for a while. And then here we've had a steady increase going up all the way to here. So even when we were at the worst that we've been with pollution, we've managed to still heat up the planet by 1 degree. Now this 1 degree, they're like, well, that's just 1 degree. Well, just 1 degree is a lot for the ocean and for the polar ice caps, and clearly for the weather, because it's changed our weather quite a bit.
Yeah, heating up, just again, something I'm really hoping that we're able to take the time and touch on a little bit more in depth when we get to next week's episode and episodes continuing on from that.
Mm-hmm.
Raising the entire temperature of the ocean by 1 degree, just consider that amount of energy necessary. Consider the amount of energy you use when you boil a pot of water so that you can make some spaghetti.
Mm-hmm.
Now consider boiling the entire Earth's water supply, fresh and salinated.
If you've ever owned an aquarium,
tremendous energy output.
if you've ever owned an aquarium and you change the temperature even a little bit, you just about kill everything in your tank.
Oh yeah, 1 degree of ocean water. It sounds like a very, very small unit of measure, and maybe we should have used a different unit of measure from the get-go when it comes to how warm and cool things are, because, you know, we're like with previous episodes right here, you don't deal with farads, you deal with microfarads. So, okay, sometimes a unit of measure is just disproportional to what it is that you're actually looking at. 1 degree over the entire body of water that is on the planet in the oceans, that's a lot of energy.
Yes, it is. And to just kind of show you, and I know I'd shown this to you guys before. This video you can actually get from NASA. They've tracked the ice pack. Now I need to explain a few things here. This ice here, this is older ice. This is ice that's supposed to stay year round. Okay, now we're supposed to have some shrinking of the ice cap, but it's supposed to return to its state here. Now this is from starting at, I believe it's 1997. I'm sorry, 1984 to 2016. So this is where we have our problem. This permanent ice that's not staying permanent, which is then kind of leaching off into the ocean here. And this is what it's like. Notice it's shrinking. And it continues to shrink all the way through. And this kind of runs for a little while. But it's fascinating to watch. And then we see here's the newer ice that's showing up in the outskirts when this was supposed to be relatively permanent in this area year round. And it's not staying that way anymore. So this water's got to go somewhere, and it's going to go into the rest of the ocean, and changes the temperatures of the ocean, and then we end up with all kinds of weird weather that's associated with that. Yeah, we're at 2016 now. Remember 1984? It was full. I mean, it's like, look, this is where we are now. This is where a permanent ice is. It kind of looks like a seahorse. It used to be a giant mass. And so that's kind of frightening to watch. I think this goes through 2016. Yeah. So if you look at our final numbers here, on here in the bottom right corner of this graph, let me go back and pause. This bottom right corner, quit that. This bottom right corner here, this is what this little white bar that was moving up and down, that was our permanent ice. This is what we got now. It's supposed to be up here, and it's down here now. And so I'm wrong about some things and precise, but just about everything else. Okay. That's fine. So, but we're supposed to have ice that returns every year, and it's not anymore. So we're losing that. And another thing, all right, so ice actually reflects light and heat. And so the more ice that we lose, this also increases the temperature of the planet, much like you don't want to wear a black t-shirt when you're jogging outside and it's like 100 degrees. Why wouldn't you wear a black t-shirt? Because it absorbs heat. You would probably want to wear a white t-shirt because that reflects heat. So the loss of the ice also can inadvertently increase the temperature of the planet because it's not reflecting that heat back. And so let me go to, that's just a pretty GIF, isn't it? It's like nice ocean. All right, so oceans absorb more light and carbon dioxide, and all of this rises and increases in temperature. So changing ocean characteristics means that we're going to have different weather. Ocean environments will then suffer because of rising temps and the lower pH. Now, carbon dioxide is considered acidic. So when you drink too much soda, it kind of burns your mouth a little bit because it's like an acid. So the increased amount of carbon dioxide, sometimes the oceans absorb that. And when the oceans absorb that, it it lowers the pH. And if you've ever had an aquarium, we've already talked about changing the temperature can affect the aquatic life. Well, guess what the pH does? The same thing.
Okay. Mel, I have to interrupt you for 1 second. Steven.
Sure.
That's a fantastic comment. And yeah, I wouldn't mind going to Greenland too. I'm just going to leave it at that.
Okay. All right. So here, here we've got Carey's Fort Reef. Starts in 1975. It's pretty much thriving. Then we have 1985. 1995, 2004, then we get to 2014, and it looks like a graveyard. So the loss of biodiversity in ecosystems, the stream flow and the temperatures change. So when we're talking about climate change being an issue, it's not just one bit of evidence. It's a whole lot of different bits of evidence put together to kind of explain why a particular thing is happening. And then the other thing we got to worry about, we now have portions of the tundra breaking off and releasing. We have an issue where we could possibly have organic material break off, increase the CO2 levels, and possible introduction of dormant microorganisms. And so that can be a genuine concern because we know bacteria can live inside organic material deep down inside the ground. And so the tundra has partially frozen soil. So if that soil thaws and breaks off into the ocean, we could be releasing brand new, well, not brand new, but old forms of bacteria that we haven't been exposed to in a very long time.
And
so that's something else
just to touch on that real quickly as well, there's also a possibility of increased methane production from soil that has not been exposed to oxygen yet.
Yes. Another greenhouse gas.
Oh, yeah. Super fun one.
Yes. So we've got that. And the last little bit of thing I have that I talk about on my other video with the same information. If you go to this website here, css. I believe it's the University of Michigan.edu, they did computational models. So we're also branching into computational science, and they've run these different scenarios, and they found that their data supports models using both natural and man-made causes, has shown that there's an increase in the temperature from their, and that kind of coincides with our observations as well, with all of the other data that we have associated with climate change. And so science is looking at this in every kind of aspect, computational simulations, in addition to what the data is from the studies of CO2 in glacial ice and all of these other things, in addition to the shrinking of the polar ice cap, the rise in the sea levels, the changes in the pH, the change in the temperature of the ocean, the death of the coral reefs. All of these are indicators that we have weird stuff going on. And then we, in addition to that, we have hotter planets, we have change in weather. This is what climate change is, a culmination of all of these different forms of evidence. So if somebody asks you for one piece of evidence, you're like, there is no one piece of evidence. There's a whole lot of pieces of evidence that explain why this is happening, because it is happening. We have weird weather and it's trends over a period of time. Why is this happening? Here's the evidence. And so that's kind of how I go about that. But I have a little thing here, so I don't know. What do I know? Nothing, I guess. That's my little spiel about what you can do on your own.
I'm like I said earlier, I'm really glad that you're joining us for this series. I think it's going to be a blast because unfortunately, we do have to deal with the fact that our world changes whether we like it to or not, and we are always going to do things to it that we might not like. But understanding what we are doing, understanding what is happening, it's very difficult sometimes for people to sit down and take a look at, okay, to hell with the fact that I may have had any part of this. You know, I have a car. You have a car. SciStrike has a car. I'm pretty sure every single person watching this has a car. We're all using the internet. We're all in some way impacting what it is that's going on with our environment. It's a natural aspect of what it is that we do as Homo sapiens. I don't want to give any of that up. But I would like to know more about it. And I would like to help everyone know more about it. And if there's that little change that you can make, this weird little thing, okay. You know, I know production of solar panels is actually pretty toxic. But in return, you're actually producing significantly lower levels of toxic materials. So it's beneficial.
Yes.
And I'm sure there's a million and one things that we could get into about it, and that's why this is intended to be a series, because we are going to go through a lot of that stuff, and I think it's going to be a lot of fun sitting down with both you and SciStrike, learning these things, that all of the aspects I don't already know, and helping people elsewhere learn all of the stuff that they didn't know. Because as intelligent as Einstein was, I'm sure that there were a lot of things he didn't know. I don't care how smart anyone is, that's not what this show is about. This show is about learning new stuff. If you don't know it, Sunday Science is going to do everything imaginable to try and help you to understand that stuff.
Agreed.
Yes.
And that's do I not always say that? None of us knows everything, but as a group, we know a hell of a lot. And it's that
Indeed.
It's that sharing. It's that sharing. That matters.
Yes.
But by the way, does anybody know how the Great Barrier Reef is doing these days? I've heard bad
personally,
things.
I haven't heard anything I haven't heard anything this year. We'll put it that way.
I haven't either. So
I've heard some distressing things in the past, and it's
Indeed, that might be something that we should collaborate on and take a look into.
I would tend to agree. All right. Mel, that was great. Thank you very much.
Well, I'm so glad you enjoyed that. I mean, I talk a bit more on my actual video, but I kind of ran through this one a little bit faster. But all of the sources are there. And if you want access to my slides, they're on my website, scientistmel.com. So all of my stuff's there. All of my shows are on my YouTube channel, and I put all my slides on my website so people can go and look at the sources and dig down a bit deeper. Use them in their classrooms or talks or whatever. That's fine with me too. Just give me a nod. So.
Well, very awesome. Just very awesome. I think this is going to be a really fun series to sit down and start actually putting the old Boilermaker to work and getting some stuff put out there.
Indeed.
I think it'll be fun.
No doubt. And all right. Ooh, Andy, check out the time. This went fun. How did that happen?
We went into overtime?
This is what happens when there's interesting content. I don't even look at the time. So, anyway, by the way, all of there will be links in the description when it's done processing. Make sure you check those out. We will certainly have links to Scientist Mel's stuff, and everybody should sub over there. Actually, everybody on Earth should sub over there because she'll help to tell you what's going on the Earth. So
Mel does have great content. I do suggest everybody, if you're not already subscribed, check out Mel's channel. Good stuff.
Indeed.
Thank you.
Good stuff. Go subscribe.
All right. Well, seeing that the time is what it is, do either of you fine humans have anything you would like to add? And at the same time, are there any last-minute questions from any of the viewers? Let me just bring this up.
I don't have anything personally. I mean, we got the side hangout running, so
Indian, that'll stay for a little bit. All right.
Yeah.
Well, nice work, you two. Nice work indeed.
All right. Well, this is fun. Thanks for having me on.
I'm glad you joined us, Mel.
It's
pleasure having you.
All righty. On that note, perhaps we should wrap it up. What do you think, guys?
Okay, that sounds good.
Yes. About that time of day.
All righty. Have a great week, everybody. Thanks for joining.
Thanks for joining us, everybody.